Next up, we're going to be talking about routers. Routers start getting really cool because we're going to start seeing how everything is coming together to make this communication happen. And routers are a big key to all of this. So in this session, what we're going to be talking about router functions, what makes up a router and how it works. We're going to talk about routing tables. We're going to talk about routes, how a router learns about different routes, and finally about routing processing, what happens with the processing of these different packets. A router's function is to forward packets, to route packets. And so that's what a router is doing. It is routing packets. And so in this scenario right here, we have a machine and it's communicating to a server over here. And what it needs to do is it needs to send it to its default gateway, so it gets it to this router. And the job of that router then is to figure out, where do I need to go next? What route does it need to take? And so this router says, I'm going to need to figure out what route it's going to take. And then it sends it along its way. Every router along the way does the same process. This router right here is going to say, okay, where do I need to send that? What is the destination IP address? And where do I need to send it next? Each one of these is called a hop. And so this router is concerned with what is the next hop. This router is concerned with what is the next hop. And then this router sends it on to that server right there. So every router is considered a hop. How do I send this to the next hop? Routers make a determination of where to route this information, where to route these packets by using a routing table. So each one of these routers has its own routing table. And within this routing table, it specifies information that gets it to the next hop. So as information comes into this router, that router is going to look at the destination IP address, where that packet needs to go to. It's going to cross-reference that with the router table and determine what is the next hop. It gets to the next router, and the router does the same thing. It takes a look at that packet, looks at the destination IP address, and determines what is the next best hop. And then this router takes a look at its routing table, realizes that that's a directly connected network, and I'm going to send it into that network so it can get to that server. So we know that a packet that comes into the router is going to look up on the routing table to determine what is the next best hop. But what is inside of that routing table? Well, the routing table has a bunch of routes in it. It's just how it can get to this location, this network. So within that routing table, it'll have a list of networks and where it is that that packet needs to go in order to send it in the direction towards that network. We call those routes. The routes are just what networks are within the reach of that router and what direction it needs to go, or what's the next best hop. And so the information will be looked up and then it will send it to the next best hop. So really our routing tables is just a list of destination networks. And so it has a list of networks and what is the next hop. So there's really three different kinds of networks that we'll see within here. One is a local network. And so here we have a directly connected network to this router. And so when we have a interface on the router and we assign an IP address to it, it recognizes that IP address that assigns to it, there's a whole network that's a part of. And so it will recognize this network right here. It's actually connected to two other directly connected networks. This one right here and this one right here. So those are all directly connected networks. Now, then it also has a destination network of possibly some remote network. So here in this example right here, we have a remote network right here that this router is going to need to know the location of this remote network right here. And so in order for it to get packets to there, then it needs to know of that remote network. So we have our directly connected networks, we have our remote networks. There's actually two more remote networks that are here, and that's this link right here and this link right here. This router may or may not need to know about those networks right there. For it to get to this final destination right here, it just needs to know about this remote network and the next hop. So it doesn't necessarily need to know about these networks right here. But in a lot of cases, for instance, if this router wants to communicate with this router, then it will probably need to know about this network right here. For the most part, there are some exceptions to that, but so those are remote networks. So then another so we've got directly connected networks, we got remote networks. We also have the machine itself. And so the machine itself, the local link, some traffic is actually destined for that router. And so it could be taking that information in, and perhaps it's some sort of management traffic to get on and SSH onto that machine, or to analyze, do some sort of network management, and so it's managing those links. And so there's reasons for us to communicate directly to that router. So we can make a connection to the router. It has directly connected networks, and it has remote networks. Now, as we mentioned, this routing table has a list of networks that are in it, and then where the destination is, what the next hop is. And it can specify this by one of two different ways. Number one is it could just specify of what the next hop address is, how it's going to get to that next hop address, or it could specify it by the exit interface. So often we'll see an IP address for the next hop interface, or we'll see just the exit interface outside of this router right here. But that's what you'll find within these routing tables. So it knows if I'm trying to get to this network, what I need to do is I need to send it to this destination IP address next. That's my next hop, or I need to send it out this interface. Okay, so we've already learned about a couple different network types. One is a directly connected network, one that's connected directly into one of the interfaces of the router, and that goes into the routing table. The reason or when it goes into the routing table is when we configure the exit interface that goes to that network, which means that we get onto that interface, we configure an IP address, we configure a mask to it. When we bring that interface up and that interface is live, it recognizes I'm attached to this directly connected network, and so that is going to be put into my routing table. It also could have a route a remote network, and it has a connection to the remote network through a next hop, through another router. And so that can go into this routing table as well. Now, one thing we haven't talked about is a default route. A default route is another type of route that we can utilize to get to different networks. So let's say that the packet comes into this router and it does not have any knowledge of this remote network over here, but it still needs to get that information over to it. And so what we can do is we can set up a default route onto this router that says, if you don't know where that network is, then what you can do is you can send it to this next hop. And then when it sends it to this next hop, hopefully this router knows of that network and knows to send it to its next hop. So that's a default route. A default route is if you can't find any other networks within your routing table that's associated with a destination IP address, then send it to this next hop. Now, typically we see that associated with a router that has access to the outside world. So on here, we'd set up a default route that says, go to this router if you can't find out where it is that you need to send this. And then this router has a default route set to the outside world or the internet or your internet service provider. So how does a router determine what is the route that it needs to go. When it's looking up its routing table, it's going to have a lot of different networks in it. And in fact, in here, there could actually be some overlapping networks that are within this routing table. Believe it or not, there could be some overlapping networks. And so what it's going to do is it's going to look for the best match or the longest match. How many bits actually lined up with this destination IP address? So we'll get more into this in the future, but essentially when that packet comes in, it's going to look at the destination IP address, and the most amount of bits that line up with that IP address, it's going to look up the network address, and the most amount it can line up with the network address, then that is going to be the route that it's going to choose to get it to its final destination. So we call that longest match, and that's how it finds the best network within the routing table of where it's going to send this information off to, where it's going to be the next best hop, the next hop in this realm to get this packet from one location to the next. So how do these routers learn of these remote networks? So let's talk about route learning and how a router learns of these different routes. Well, for one, a router can have static routes set up in it. And so what a static route is it's an entry that you manually set up onto the router. So you go and manually set up a route, and that is a static route. We call it a static route because it doesn't change. It's not dynamic at all. And so we could go into this router and we could specify this network right here, and we could specify how to get there, which would be the next hop pointing to this router right here. And we may specify a IP address that is on that router, that next hop router, or we may specify a exit interface. And so then what we do is we'd specify that, so that way when it sees a packet that's coming through that's destined for this remote network, then it would take that static route to take that next hop. But there is another way as well, and that is through a dynamic routing protocol. A dynamic routing protocol is a way for routers to share information about the networks that they're connected to. So here we have several routers here with routing tables, and what they would do is they would share the information from their routing tables back and forth between these routers. And so this router would then learn about these distant networks, possibly this remote network and possibly these remote networks, so that way it could get to those destinations by one of the routes that it has available to it. So in this case right here, this router would learn that this remote network is accessible either through going through this router right here or going through this router right here. That's done with a dynamic routing protocol. So these dynamic routes will be learned from a dynamic routing protocol. This does two things for us. One is with a more larger complex network, we don't have to sit there and manually enter a bunch of static routes onto our routers. And so it really saves us a lot of time. But another thing is because it's dynamic, if something happens, like let's say a link goes down, then the router will know how to adjust and get to that remote location, even though there's a downed link somewhere in between. And so that is how dynamic routing protocols work. Some examples of that might be RIP or OSPF or EIGRP are some routing protocols that you would set up on every single router that you would want to participate, and then that would start a communication back and forth between these routers to share these different routes and to share what's on their routing table. So what that routing process looks like is a frame will actually come into this router, and that router will process that frame just like any other machine would process that frame. And that would be the layer 2 information that's in there. it's coming into that router. And so then once that router determines, well, this layer 2 is destined for me, the MAC address is destined for me. Now what I need to do is I need to figure out what network this is going to be sending to. So it takes a look at the layer 3 information. And so it takes a look at that layer 3 information and matches it up against its routing table to determine what is the next best hop. And so it's going to determine what the next best hop is. Once it does that, it's going to take that time to live and it's going to decrement it by 1. So that way, whatever that time to live is, it's going to subtract 1 from that. And that means that if there is a routing loop at some point in time, that packet would die and it would not continue to live forever. And so because it decrements that time to live on there, it also has to adjust the checksum that was within the IP header. So it adjusts the checksum. And then once it's done that, then it can forward that information onto the next router, that next hop. But of course, to do that, to put it onto this physical line, it's going to need to reform a new layer 2 header and then use layer 1 to physically put it on the line to get it on its way. So that is the routing process. That's what routers do to process the packets that are coming into it, so that way it can send on to the next hop to get it pushed along its way, and finally, at some point in time, getting to its final destination. So in here, when we were talking about routers, we talked about the router's function. We talked about the routing table and how the routing table is set up. We talked about how routing tables have routes on them, and the routes have some sort of next hop on it, has a network and the next hop for that network. And then we talked about how it could learn. We talked about both static and dynamic routes. A static route is something you set up on the router. A dynamic route is learned through other routers, and it can be learned through a dynamic routing protocol. And then finally, we talked about the routing process, what a router will do to process the packets and forward it on to the next hop to get it to its final destination. Hope you're enjoying the videos. If you like them, could you hit that like button?